In this lesson, we're going to talk about how to find perpendicular bisectors in the coordinate plane. So the first thing I want to do is just remind you when we're looking for an equation of a line, which in this case will be a perpendicular bisector, just some different rules for the formula. So the first thing I want to do is just talk about some different scenarios. So I'm just going to label some axes up here. So I have x, y. I'm just going to draw 3 pairs here, x, y, and then x, y. So just remember, if you have an equation or if you have a line that's diagonal, so something like this, the equation of that line is going to be y equals mx plus b, where m is the slope and b is the y-intercept. So in this case, this would have a positive slope. And then the other 2 situations I want to talk about is what happens when you have a vertical line. So vertical lines, remember, have undefined slopes. And this equation is going to be x equals whatever the number it's passing through. So it's going to be x equals the number. So the reason for that is because every point on this line, x would equal, like let's say that this was at 5. Every x value is going to equal 5, but all the y values are changing. So it's x equals a number. Now if I have a horizontal line, let's say that this is passing through the y value of 5, that's going to be y equals the number, or y equals 5 if it's passing through 5. And that's because on this line, the y value is going to stay the same, but what's changing is the x value. So this has a 0 slope, so that's why if you think about it as y equals mx plus b, there's no mx term because it's a 0 slope, and 0 times anything is 0. So really, it's just y equals b. It's the y-intercept that it's going to equal. So those are your 3 different scenarios that you're going to have. And the reason why I talk about that is because if we're trying to find the equation of a perpendicular bisector, you could have any of these 3 scenarios. And we're always going to be looking for the perpendicular bisector, which means the slope will be flipped and negated, with the exception of horizontal and vertical lines. Those are always going to be perpendicular to each other. So you're not going to necessarily see that they're negative reciprocals. It won't look like it because of the 0 slope, or the undefined slope, meaning 0's in the denominator. But you just have to know horizontal and vertical are always perpendicular. And when we have a diagonal line like this, you flip and negate the slope. So let's go ahead and look at this first example. So write an equation of the perpendicular bisector of the segment connecting the points A, which is 1, 5, and B, 7, 5. So let's go ahead and look at this on the graph. So 1, 5, so over 1, up 1, 2, 3, 4, 5. So that's going to be point A. Point B is 7, 1, 2, 3, 4, 5, 6, 7, then up 5, 1, 2, 3, 4, 5. So you end up with this horizontal segment, which means the perpendicular bisector would have to be vertical. And if you think about perpendicular bisector, there's 2 things. It has to be perpendicular to this segment, and it has to bisect it. In order to bisect, it has to go through the middle. So it's easy enough for me just to count the distance. So 1, 2, 3, 4, 5, 6. So I had to go over 6, which means if I'm trying to find the midpoint, it's just half of that. So over 1, 2, 3. So here's the midpoint. I'm going to call it M. The perpendicular bisector has to pass through that midpoint and be perpendicular to the red segment, which the horizontal, if it's a horizontal segment, the perpendicular bisector has to be vertical. So this would be our perpendicular bisector. To write the equation of it, well, it's a vertical line, so it's going to be x equals. So I just have to count 1, 2, 3, 4. So the x value is 4. So it says write the equation. So the equation is going to be x equals 4. Now, just to kind of show you that you can do this on a graph like what I just did. But remember, in the last lesson, you guys talked about constructing a perpendicular bisector with a compass. So watch what happens if I apply that here. If here's my segment, if I go and I do the construction on the segment of a perpendicular bisector, well, that means take your compass more than halfway. You got to make sure it's right on the intersection there. And if I make an arc, and then I move the compass over here, and making sure it's as close as possible to being on that intersection, make an arc, and you can see that the perpendicular bisector that I found using the coordinate graph is the same thing as doing the construction. So it should work out that way. So if you can't figure it out on a graph, well, you could always do the construction and then find the equation of the line afterward. So that's another option for you. So let's look at the next example. So we have these 2 points. So I'm going to start with that. So we have C is 2, 6. So over 2, up 1, 2, 3, 4, 5, 6. Make sure we're labeling. B is 2, negative 9. So right 2, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I'm starting with a vertical segment, which means perpendicular to this is going to have to be horizontal. So I got to find the midpoint. So the distance from C to B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I went down 15, which means if you divide that by 2, you're really going to have to go down 7.5. So you go down 1, 2, 3, 4, 5, 6, 7.5 would be right in here. So there's going to be my midpoint. Remember, the perpendicular bisector is going to have to be horizontal, so it's going to be horizontal passing through that midpoint. So here's that. And I'm going to put my arrows on because remember, perpendicular bisectors can be lines. They could be segments. You don't have to have the arrows, but I'm just going to go ahead and put the arrows. Since it's a horizontal line, it's going to be y equals, and then I just have to count the y value. So the y value is 1.5, negative 1.5. So the equation for this one would be y equals negative 1.5. Now keep in mind, if I take my compass, you'll see that you'll end up with the same thing. So go more than halfway, draw your arcs, and then go over to the other side. You have to be right on that intersection. Draw your arcs, and you can see that the line that I came up with is the same thing as doing the construction, and it should be. So the answer for this one is just y equals negative 1.5. So the last one I want to look at is what happens when, so I'm going to skip down to the bottom for a second. What happens when you're given 2 points and it's not a vertical or horizontal line? So let's look at this example. So we have 3, 6 is where we're going to start. 1, 2, 3, up 6, 2, 4, 6. Got to get the point. So 3, 2, 4, 6. Labeling that A. B is 5, 2. 1, 2, 3, 4, 5, up 2. So here's my original segment. The problem with this original segment is that it's not horizontal or it's not vertical. It's a diagonal. So you can't just count, find the midpoint, and then draw the line that's perpendicular without doing some more math. Like you have to know, first of all, you have to know where the midpoint is, which that's easy enough to find. But then you have to make sure that when you go through the midpoint, you're perpendicular to this segment. So we're going to write the steps that we're going to take up here, and then we'll actually go through and do it. So the first step, so this is the question, how do you write the equation of a perpendicular bisector formed by 2 given points? So the first step is you're going to find the midpoint. That's what we did on the last page. We found the midpoint. You always have to start with finding the midpoint. And you can find the midpoint using the midpoint formula or by counting on the graph. Then, since on the previous page we were given either a horizontal or a vertical segment, we knew the slope, and then we just knew that the perpendicular would be the opposite. In this case, we're going to have to find the slope. So you're going to have to find the slope of the original segment. And the reason why you find the slope of the original is so that you know what the perpendicular slope has to be. So once you find the slope of the original, then you're going to find the slope of perpendicular bisector by flipping and negating the original slope. Which is the slope from number 2. From step 2. So then from there, you'll be able to draw the perpendicular bisector, but you're trying to come up with the equation. So once you know what the perpendicular bisector looks like, you have to know the y-intercept to be able to write the equation. So you're going to find the y-intercept, and you can do this on the graph, or you can plug in. If you remember when we had those problems where we had a parallel line or a perpendicular line passing through a specific point, you always had to plug in the slope and the point, and then you'll find the y-intercept. So since we know the point, we know the midpoint, that's the point it has to pass through, and we know the perpendicular slope, we can plug those two things in into y equals mx plus b. So we can use y equals mx plus b and plug in the midpoint and perpendicular bisector slope and solve for b. Otherwise, you're doing it on the graph. You just got to figure out where does it cross the y-axis, and you'll know the midpoint and you'll know the slope, so you just count until you get to the y-intercept. And we'll look at the example for this. And then the last step, once you know those two things, once you know the y-intercept, you know the slope, you can write the equation. Using the perpendicular slope, which is the perpendicular bisector slope, and the y-intercept. So basically you use number 3 and 4 to do that, those two numbers from 3 and 4. So let's go ahead and actually do this. So we start off with find the midpoint. So I'm going to use the graph to do this, but keep in mind you could use the formula, up to you. So remember, to find the midpoint, you count 1, 2, 3, 4. So it was down 4, and then over 1, 2. So the midpoint's going to be half of that, so down 2 over 1. So here's the midpoint. So the coordinates of the midpoint are going to be 1, 2, 3, 4, up 1, 2, 3, 4. So it's going to be 4, 4. Then I'm going to find the slope. Step 2 is the slope of the original. So that means slope of AB. That's my original segment. So since I've already counted down and to the right, I know that the slope of the original is down 4, right 2. Since it's down, that tells me it's going to be negative 4 over positive 2 since you went to the right. So that's going to end up being negative 2, which then tells me the slope of the perpendicular. So the slope of the perpendicular bisector will be flip and negate this. So remember, this is like negative 2 over 1. So if you flip and negate that, the perpendicular slope is going to be positive 1 over 2, which means on the graph, you're going up 1, right 2. It's always rise over run. Since it's positive, it's up. So that means the perpendicular bisector is going to go up 1, right 2, up 1, right 2. So this is going to be my line, and then go backwards, down 1, left 2, down 1, left 2. And you can keep doing that. And if I connect them, that is the perpendicular bisector. So this would be the perpendicular bisector. And if you remember the previous page, instead of just like on the previous page, we could just take the segment and then just draw the perpendicular. This one, we had to know the original slope so that we could flip and negate, so that we made sure it was perpendicular. So this, I'm just going to make this blue. Maybe I won't, depending on if it'll allow me. All right, I'm just going to leave it. So I have, here's my perpendicular bisector. We know the slope was positive 1 over 2. My y-intercept is easy enough to see right here. So the y-intercept is right here. So the y-intercept is going to be 2. Now, remember what I said, step 4, to find the y-intercept, you could plug in. So if I plug into y equals mx plus b, you plug in the point that you want your equation to pass through. Well, I want my line to pass through the midpoint, so you use the midpoint and you use the perpendicular slope. So you have to make sure that you use the perpendicular and the midpoint because you want it to have the perpendicular slope and pass through the midpoint. So that means I would be plugging these in for x and y. So I have 1/2 for the slope, 4 for x plus b. And then when you solve this, this gives you 2, 4 divided by 2. Subtract 2, so you get 2 equals b, which is exactly what we found on the graph, but this is the algebraic way of doing it. And then the last step is just to write your equation. Well, if you know your slope, so we know the slope and we know the y-intercept, so now we can take these two things to come up with the equation. So it'll be y equals, your slope is 1/2 x, and then plus b. So that would be your equation, and if you look up top here, that matches. It's a slope of 1/2, y-intercept of 2. So 1/2 x plus 2. Last thing I want to show you, if I apply the compass here and I do the construction of the perpendicular bisector, you're going to see that you get the same line, and then you would just have to come up with it. So what I could do is I could take my compass, I could go more than halfway, draw your arcs, go to the other side here. You have to make sure that you're very careful about being on the actual corner. And you'll see, here's my intersections, they cross at this perpendicular bisector line, which if you didn't do all this algebraic stuff, you could start with your construction, get your line drawn, and then come up with the equation based off of that. So count the slope of the line, count the y-intercept, and it would give you your perpendicular bisector.